Good afternoon, students, and welcome to today's session. So let us start with the discussion of any doubts and questions that you have from Newton's laws of motion, especially from H.C. Verma questions. And then we will move on to friction today. We'll discuss some basic concepts related to friction, etc. I think this is session number 9 for us for Newton's laws of motion. So as I said, let's discuss some questions and doubts from H.C. Verma. So if anybody has a doubt in the first 10 questions from H.C. Verma, please drop me a message on the chat and let me know. I will discuss. Anybody has doubts from question number 1 to 10, anything? Okay, question number 4 and 7. Let's start with that. So let's start with question 4. So it says that a block of mass 0.2 kg is suspended from the ceiling by a string. Second block of 0.3 kg is suspended from the first block through another string. Find the ratio of the tensions in the two strings. So let me just explain the diagram, and then I think it will be clear to you how to work out this question. So what is happening is, from the ceiling we have used a string to suspend one block like this, and then we are suspending another block from the first one using another string. Okay, so this is the concept of the question. So let's say this is block A, this is block B. Now if the tension in this string is T1 and the tension in the second string is T2, given that mass of the block A is 0.2 kg and mass of the block B is 0.3 kg, we have to find the ratio T1 is to T2. Okay. So how to do this question? Very simple. Make the free body diagrams of A and B. So for A, you will see the forces acting are tension T1, tension T2 from below, okay, and its own weight. So we have the equation and it's in equilibrium. So T1 is equal to T2 plus weight of A. Okay. And similarly, if you make the free body diagram of the block B, you can see that there are only two forces acting on it. Tension T2 and weight. This is also in equilibrium. So T2 is equal to weight of this. Okay. So from equation 1 and 2, you can see that T1 is equal to MA plus MB G, and T2 is equal to MBG. So T1 is to T2 is the sum of their masses is to the mass of B. So that is going to be 5 is to 3. So that will be the ratio of the tensions. So this should be your answer. Okay, we'll discuss the sixth and seventh question next. But those who have the doubt in the fourth question, please note this out down first. Oh, they've asked to actually find the tensions. So you can directly see that this tension will become 0.5 G or 5 newtons because G has been given as 10 meters per second square. So that is 3 newtons. Okay. So your final answers are 5 and 3 newtons respectively. Okay. Now go through the sixth and seventh question next. We will discuss about that. Okay, so hope that this question is clear. Aditi, you have understood this question? Okay, good. Let's move on to sixth question. Okay, so question 6 is giving you the graph of velocity versus time for a particle of mass 50 grams. So start by understanding that you have velocity on the y-axis and time on the x-axis. Velocity expressed in meters per second and time expressed in seconds. Now the graph is of this type. It starts from 0 with a velocity 0. That means the particle is at rest initially, and it increases like this linearly with time, then remains constant for some time, and then again decreases linearly. Linearly का मतलब क्या है? Straight line graph. So as per the graph that is shown, these two times and this velocity's value is something like this: 5, 10. This is 15 meters per second. Similarly, this is 2, this is 3, this is 4, this is 5, 6, and 8 seconds. Okay. Now they've asked you to, so this is the velocity time graph for a particle of mass 50 grams, okay, which is moving along a straight line. So we have to find the net force acting on it. We have to find the net force acting on it at the instant t equal to 2 seconds, t equal to 4 seconds, and t equal to 6 seconds. Okay. So now in this, what we'll do is, first of all, we'll use Newton's second law, that the magnitude of net force is equal to mass into acceleration. And then we'll use the principle of straight line motion, that acceleration is rate of change of velocity with respect to time, where this is nothing but the slope of the velocity versus time graph. So this dv by dt is the instantaneous rate of change. So instantaneous rate of change graph में क्या होता है? It is the slope. So for example, you can see over here that between this and this time, what is the slope going to be? So from t equal to 0 to t equal to 3 seconds, that is from this point to this point, you can see the slope is change in velocity upon change in time. So that is like v2 minus v1 upon t2 minus t1. So this point has v2 equal to 15 meters per second. This point has v1 equal to 0. Divided by here the time is 3 seconds. Here the time is 0. So the acceleration is equal to 15 by 3 or 5 meters per second square. So that is the acceleration. So for any instant between this and this, the acceleration is like this. So therefore, at t equal to 2 seconds, the acceleration is 5 meters per second square. So the force is 15 to 10 raised power minus 3 into 5. Okay, so that is 0.25 newtons. This will be the force acting. Okay. Now similarly, you work out that at 4 seconds, the time is this one. What will be the slope? Here the slope will be 0 because it's a straight line. So what about the acceleration here? It should be 0. So force should be 0. Whereas here the acceleration was 5 meters per second square. Now similarly, at this part, you can see that the slope is equal to minus 5 meters per second square. Because again, you can see that for this part, delta V by delta T is 0 minus 15 upon 8 minus 5. So that is minus 5 meters per second square. Okay. So that means the magnitude of acceleration is only 5 meters per second square. Or you can see that at 6 seconds, there is a deceleration of A equal to of magnitude 5 meters per second square. So again, the force, if we write with sign convention, we should write it as minus 0.25. Okay, but if you just write the magnitude of the force, it's 0.25 newtons. Okay, so is the question clear, Sanya? That is why they're given the answer 0.25 newtons opposite to the motion for C part and 0.25 newtons along the motion for A part. Whereas for B part, it is 0. Okay, good. Now let's move on to 7th question. So number of people have asked 7th question. Bhavna, Ruksar, etc. So let's go through the language of the 7th question. So I'm sure you'll be able to solve this question yourself. It is just a matter of understanding the language of the question. So what is happening in question 7, that you have two blocks of mass Ma and Mb. They are kept at contact with each other on a frictionless surface, and the experimenter is pushing block A from behind so that both the blocks accelerate. Okay. So this is first of all the situation that, let's say this is block, this is the first block, and now against this we have kept the second block in contact with it, and both the blocks are placed on a frictionless or smooth horizontal surface. And what is happening is that the experimenter, it says, is pushing the block A with a certain amount of force. So this is not the force F that they've given. This is the force that the experimenter, so let's say that is the external force that this is applying. So as a result of this force, both the blocks are accelerating together. Okay. Now given that the block A pushes B with a contact force, what type of force? It will be a contact force equal to F in magnitude. So this F is basically what? It is the normal reaction contact force on B by A. So from this we have to find what is the force applied by the experimenter. We have to find this out. Okay. And given that A has mass equal to ma and B has mass equal to ma. Okay. So it all really comes down to making the free body diagrams. Now here what we can do is that, just to make things convenient, because A and B are moving together, okay, like a single body, we can make a free body diagram for A plus B as a combined body. That will make things very easy. So if we think of A plus B as a combined body, then on that horizontally we have to consider only one external force, this one. Okay. The other forces are vertical. It will be the combined weight, and there will be the normal reaction from the ground, which is the combined normal reaction on A plus B. But that doesn't really matter so much because the acceleration is horizontal. So we'll get the equation that F external is equal to ma plus mb times A. Okay, this is our first equation. Now we need to find out the value of A here. Okay. So to find out the value of A, next what we can do is we can make the free body diagram of the block B alone. So if you look at the block B, what is happening is that when we are pushing A with a force like this, A is pushing against B with some normal reaction, let's say N1 like this, and B is pushing A back with N1, and this N1's magnitude is only given to us as F, because this is the normal contact force, the normal reaction between A and B. So यही वाले force का जो magnitude है वो मुझे दिया हुआ है question में as capital F. Okay, and this is creating the acceleration E. So if I make the single free body diagrams of A and B, this is how they will look. It will be like this. Okay. So for A, we'll have the equation F external minus N1. I'm not showing the vertical forces, is equal to this. Okay. Or even better for B, I have N1 is equal to mass of B into A. So N1's magnitude was only F. So F is equal to MB into A. So take this as your second equation. Now next what we do is from equation 2, you take the acceleration as F upon MB, because acceleration was unknown here, and substitute this in equation 1. So you get the unknown quantity F external, which is MA plus MB into acceleration, which is now F upon MB. So you can see that in terms of capital F, the external force applied by the experimenter, that is given by this expression. This is the final answer. So ultimately, it is just a matter of solving the free body diagrams and eliminating the unknown quantities from the given quantities. So what were the given quantities? Given quantities were the two masses and this force that is the contact force between A and B. From this, which is the unknown quantity, we are getting the external force. But by doing what? By eliminating the acceleration. Okay, good. So hope Bhavna, you have also understood the question. Now we'll move on to 10th question next. Okay, make a note of this. Then we'll move on to 10th question. So 10th question is related to spring force that we were discussing in the previous lecture. So good place for us to revise the concept of spring force. Just finish writing this down and read through the 10th question. I'll explain it in detail to you. All right, so let's start with the diagram of the 10th question. So we have this kind of a situation. There is a block, okay, which is attached to, which is first of all placed on a frictionless surface. And on either side of the block, there are two springs attached, okay, which are attached finally to a wall on the other side each. So there is one fixed wall on this side. There's one more fixed wall on this side. And for the given position of the block, both the springs are currently in what is called the unstretched position. So unstretched matlab kya? Natural length position. They are neither compressed nor extended. So smooth surface. Now this has a spring constant K1 and this has a spring constant K2, and both springs are at the natural length position. So natural length position means that tension in the spring is zero because the x of the spring is zero. So remember, tension was kx in magnitude. Okay. Now if the block is displaced by a distance x and released, what will be the initial acceleration? So let us say now from here what we are doing next is we are displacing the block by x. So let's just assume some particular direction of x, but I'll show you later that it doesn't matter which direction I take, right or left. It will give us the same result as far as the magnitude of acceleration is concerned. So anyhow, when we displace this block by a distance, let's say x, now I'm taking in my diagram that displacement is towards the right. So the moment I displace this block towards the right by a displacement of x, so what is happening? This is x. Okay. This is also x. No. So what is happening is that this spring, the K2 spring now, it is compressed by a distance of x. The spring having spring constant K2, this one, इसका length compress हो गया है. It is whatever the original length was minus x. Like the original length in this diagram of the spring, the natural length was L2. So now this is compressed by X. Okay. And if this spring had a natural length of L1, what has happened to this spring? It has got elongated. Stretch हो गया ये spring. It has got elongated by how much? It has got elongated by X. Okay. So this is suffered an elongation X. And this one has suffered a compression of X. Okay. Now you know that when a spring is elongated, what type of force it applies at the two ends? An inward force now. ऐसा force लगता है kx. Whereas when a spring is compressed, we compress a spring by x, the force acts outwards. It always tries to restore the spring back. So here you can see that this one is compressed, so it will apply force like this, k2x on either side. And this one is elongated, so it will apply inwards force on either side. So if you see the free body diagram of the block, what is happening? The spring from this side is pushing it with the force of k2x, and the spring from this side is pulling it with a force of k1x. So it will accelerate in this direction. And of course, vertical forces are balancing. So what will happen? The net force will be k1x plus k2x. So it will have an acceleration of k1 plus k2 upon mx. Similarly, you will notice that if I displace the block in the opposite direction, अगर मैंने block को natural length position से ऐसे displace किया होता है x से, then what would have happened is this spring would have been compressed and this spring would have been elongated. This would have been compressed, this would have been elongated. So this would have applied a force k1x like this would have applied a force k2x like this. So once again the block would have an acceleration in this direction. It would be the same. Okay. So it will have an acceleration like this such that the direction of x or direction of the acceleration a is opposite the displacement x. If the displacement is towards the left, the acceleration is towards the right and vice versa. But the magnitude of the acceleration each time is this. So hope the working is clear to all of you. Please make a note of this, and after this we will do question 11. So if you've done question 10 already before, go through question 11 next, we'll discuss. Okay, next let's discuss 11th question. 11th and 12th, both of these questions we'll discuss next. So 11th question is also actually very simple. It's just free body diagram based. So you have to just understand in this question that there is no friction between A and B now. So between the blocks A and B, there is only one kind of contact force, and that is the normal contact force. There is no frictional force. So that is why if I push the block A horizontally with an external force, it will not have any horizontal effect on B. B will just remain the way it is. If I am applying a force like this on A, and it is given to me that this length is given as 20 centimeters. So mass of A is given to me as 5 kg, and this force I'm applying is given to me as 10 newtons. Okay, and this length L is given to me as 20 centimeters. Mass of B, by the way, is not given. Okay, but you have to find the time before B separates from A. So first of all, let's understand why B will separate from A. So for that, you need to understand the free body diagram. So क्या हो रहा है? A पे और B पे what type of forces are acting? Let's understand. So free body diagrams of A and B. So obviously there is weight of B acting downwards. There is weight of A acting downwards. Then there is some kind of normal contact force between A and B. So B is applying an upward normal reaction on A, and A is applying an equal and opposite downward normal reaction on B. So let's say this contact force is N1 in magnitude, and the ground is applying some kind of upward normal reaction on B. So that is like this, N2, that the ground is applying. So these are all vertical forces and they are balancing. So you can see that vertical forces are balanced for both the blocks, for E and B both. So normal reaction acting on E is balancing A's weight, and normal reaction acting on B is balancing N1 plus its weight. So balancing the combined weight. But now the most important thing, this horizontal force that I'm applying on B, there's nothing to balance it. Okay. So B will immediately develop a horizontal acceleration of, whereas A has no horizontal force acting on it. So acceleration of B is A horizontally, but acceleration of A is 0 because there's no horizontal force on it. So B has a horizontal acceleration E such that F is equal to mb into A. So that acceleration is F divided by mass of B. So that is nothing but 2 meters per second square. So now back to this diagram here, the original diagram. Now you can understand in this what is happening is that the upper block is remaining stationary till it slips off. Okay. So this block is remaining at rest, whereas the lower block is slipping with an acceleration of 2 meters per second square. Okay. So this was the position of the system at t equal to 0. This block was at rest, but at some time it will become like this now. A would have moved to this position. So it would have made a displacement of S in this direction. Okay. So that S is equal to half AT square. Whereas this block will remain here only, it's not going anywhere. So at some time t, A has moved here, but B has remained here only. So when S becomes approximately, now you're neglecting the size of the object B compared to the size of A. So you're thinking of it more like this. So by the time B has moved here, this is when this object will be ready to fall. So B's displacement needs to become equal to its length. So that is the thing. So half into 2 meters per second into t square needs to be the length of B, which is 20 centimeters given to us. So 0.2. So the time will be square root of 0.2 seconds, or the time is 1 by root 5 seconds. At this time, what is happening? B will fall off A. Okay. So make a note of this, please. Yeah, so we'll come to 12th also. Note this down first, then we'll come to 12th and 14th question. Okay, so if you calculate this, 1 by root 5 we can write as root 5 by 5, which you can write as approximately 2.2.23 so that becomes approximately 0.45. Okay, so the time is 0.45 seconds, or more accurately it is 1 by root 5. Okay, let's move on to question 12. So in question 12 we have this kind of a situation. So now you are applying some kind of force from either side of these two threads, and that will become equal to the, now why I'm taking tension same on both sides is because it is symmetrical. So this person who's fallen into the ditch, suppose his mass is m. Now this mass m is being lifted very slowly. So if it is being lifted very slowly, that means this upward acceleration is tending to zero, because it is being, the person is being lifted slowly. Okay. So if you make the free body diagram of the person, you can see that there are two tensional forces acting like this. Okay. And let us say that they are acting at some angle theta like this to the vertical, and they are balancing the weight, because there is acceleration upwards, but that acceleration is tending to zero. So you get the equation that 2t sine theta, sorry, 2t cos theta, that is the net upward components of the two tension, is balancing mg. So tension is equal to mg by 2 cos theta. Okay. This is your first, let's say this is your second equation. Of course, you know that F is equal to T. Whatever force you're applying, that is the tension. So this is in fact our first equation. Yeah. So combining these equations, you can see that basically F only is equal to mg by 2 cos theta. Now, it's also given to you that the depth of this person in the ditch, this is h. Okay. And the width of the ditch is given to us as, what is it, d, right? The width of the ditch is given to us as d. So here this is d by 2 and this is d by 2. So if this angle is theta, you can see that we have in that triangle so in this triangle you can see the value of cos theta is equal to how much? H upon root of h square plus d square by 4. Okay. So use this over here now. So F is becoming mg by 2 cos theta. So that is h upon square root of h square plus d square by 4. Or we can write it as mg by 2 square root of h square plus d square by 4 divided by h. Now we can take h inside the square root. Okay. So F becomes mg by 2 into square root of, when you take h inside, this becomes 1 plus d square by 4 h square. So in this you can see, okay, as the person is moving up, okay, h is decreasing. Okay. Therefore F will increase. You can see in the formula here, if this denominator is decreasing, this whole quantity is increasing. So as h is decreasing, 1 by h square increases now. So therefore 1 plus d square by 4h square, this thing increases. Okay. So therefore F increases as h decreases. Okay. So obviously free body diagram is coming into play, but also a bit of the mathematical equation setting where you understand the relationship between F and H. And so you understand here that D is a constant during the motion. Okay. But H decreases as the person is pulled up. So as h decreases, F has to increase. That is what the question is asking you to show. You have to find the force. Okay. So you have to show that the force exerted by each friend on the rope increases as the man moves up, and find the force when the man is at a depth of h. So as a function of h, when he is at a depth of h, this is the value of force. And from this formula itself, you can see that as the person being pulled up is going up, his height is decreasing, his depth h is decreasing from the top. So accordingly, the amount of force that has to be applied from either side on the rope, that has to increase. Okay, so this is an important question. Make sure you understand the solution properly. And after that, come to question number 14 next. We will discuss. So note this down and come to question 14. Hitanshu, which question you are talking about? Is the same answer, beta. इसको थोड़ा solve करो ना. You have to learn to do a bit of solving yourself ना. यहाँ पे just take the LCM ना. This quantity mg by 2. Okay. Just solve it a little bit further. You will get the answer. Everything I should not have to spoon feed you here. Okay, so you can also write it this way. So this answer given at the back is the same thing as this. There's no difference between the two. Kunj, which question you're talking about? Pseudo force? Because we haven't solved anything in non-inertial frame so far in these questions. Okay. Pseudo force will come only into the picture when we are discussing about non-inertial frame. Oh, question 14 you're talking about. Yeah. So in question 14, we will be making use of non-inertial frame. But so far up to question number 12, we have not made use of non-inertial frame anywhere. So that's why pseudo force is not featured. Yeah, in question 14, when we discuss next, you will see that there is application of pseudo force concept. So now let's see. So pendulum of a bob of mass 50 grams is suspended from the ceiling of the elevator. Find the tension if the elevator is going up with an acceleration. Okay, so let's take the first part. So here what is happening is that the elevator is going up with an acceleration. So its velocity is also upwards, its acceleration is also upwards. Because it's going up, that means the direction of motion is upwards, and accelerating means the direction of acceleration is also upwards. Now inside this we have the pendulum suspended by a thread. So it's like a bob of certain mass given to us as 50 grams suspended like this. Okay. So we have to find the tension in this case. So here there are two ways we can do this. We can take the frame inside the elevator. So from that non-inertial frame, which is inside the elevator, so that frame itself is going up with an acceleration of 1.2 meters per second square. But in that frame, what is the state of the particle or the bob? It is at rest. With respect to this observer, the object is at rest. But of course, with respect to this observer, there is pseudo force. And the direction of pseudo force will be opposite to acceleration. And the magnitude will be ma. So this is pseudo force. Okay. Tension upwards. And of course, the body's own weight. Mg downwards. So net force should be 0. So tension is balancing mg plus pseudo force. So the tension should have a magnitude of m into g plus e. So this is 50 into 10 raised to power minus 3 kgs. It become 9.8 plus 1.2. So that is 11. So this will become 0.55. This will be the tension in the first case. Now likewise, we'll discuss a couple of other cases also. But in the first case, the tension will be like this. Now you can also solve this in ground frame. If you solve this for another observer who's on the ground, so with respect to this ground frame observer, what is happening is, if the inertial frame fixed to the ground. Now in this frame, obviously there's no pseudo force on the bob, but the bob itself he will see going up with an acceleration E. For him, it will not be at rest because he's seeing it from the ground. So for him, he will say that tension exceeds the weight. He will say T minus mg is equal to ma. So that will give him the same result. Okay, so hope the first part is clear. Let's discuss about part B next. Part B is saying that he's going up but with deceleration of 1.2 meters per second square. So going up with deceleration means the direction of acceleration is what? Downwards. So the direction of acceleration is downwards. What should be the direction of pseudo force? It should be upwards. So accordingly, we have to solve. So in this part, the elevator was going up with acceleration. (1.2 meters per second square). That's why my direction of velocity is also upwards, and my direction of acceleration is also upwards. Okay, so Kunj, hope this is clear to you, the first part. Okay, now let's look at the second part very carefully. So once you're clear about pseudo force, solving is not difficult, but you have to understand the language of the question. So in second part, what it's saying, the elevator is going up, but with a deceleration of 1.2 meters per second square. So what does this mean in terms of the motion of the elevator? Its velocity vector is going to be upwards at any instant, but its acceleration vector is going to be at what direction? Downwards. This is the thing we have to be careful about. Okay, going up का मतलब जरूरी नहीं है that it has to have an acceleration upwards. Going up just means that its velocity vector is upwards, but because it's decelerating, going up with deceleration, so acceleration vector has to be opposite to deceleration vector. So the acceleration is 1.2 meters per second square, direction is downwards. This is the meaning of deceleration. Okay. So this time when you suspend the object inside, the direction of pseudo force if you are in the non-inertial frame will be where? Upwards. So if I'm solving in the non-inertial frame, so I'm in the non-inertial frame of the elevator. So this time my non-inertial frame is having a downward acceleration of E. So the particle is at rest with respect to me will experience a pseudo force upwards. It will be the pseudo force. And of course, there's tension T acting upwards and the weight of the block acting downwards. So if it is at rest, the sum of tension and pseudo force is together balancing mg. So in this case, the tension will become this much. So it will become 50 grams multiplied by 9.8 minus 1.2. So the tension will be like this. Okay. Now likewise, in the C part, what is happening? The elevator is moving up with uniform velocity. Elevator has uniform velocity. That means acceleration of the elevator is zero. That means no pseudo force acts. So tension should be equal to mg. And likewise, you can work out the D and E part yourself by taking the correct direction of pseudo force according to the correct direction of acceleration. Okay, so hope this is clear. Now, any other question before 19th question? Seventeenth and 16th. Okay, we'll discuss. Okay, so no problem. Let's solve some more questions. So next we will discuss about question 16. So go through it carefully. Okay. This is the same level of questions we have done in the last lecture. So you will not have any difficulty understanding this. So go through question number 16. Okay, so let's understand question 16 next. So before we get into question 16, let us understand the functioning of a spring balance. So how a spring balance functions. So a spring balance basically measures the weight of an object, okay, by a measurement of the tension in a spring used to suspend it. Okay. So basically, if we have a spring balance which has like a scale like this and a pointer, and we use it to suspend an object of mass m, the spring balance itself is suspended from a fixed ceiling, let's say. So what happens is that the tension here is equal to mg, and inside the spring balance we are having a spring actually, and that spring stretches according to the amount of tension that is acting here. So inside that there is a spring. That spring is elongated according to the tension. So kx is equal to t. So by measuring the extension of the spring, it is measuring the tension. So ultimately the spring balance measures the tension equal to the weight. Okay, so for example, if m is equal to 20 kgs, the spring balance reading will be that it is 20 g, because the tension in the string, the tension within the spring will be equal to mg, which will be equal to 20 g. Okay. So this is how it ends up measuring the weight of an object. Okay. Now in this particular question, in the 16th question, what is happening is we are using a spring balance, but not to directly suspend a single block from a fixed ceiling, but we are using it for a rather more complicated situation. We are using it in a situation like this, where inside an elevator we have placed this spring balance. So the elevator itself is accelerating upwards at an acceleration of g by 10. Inside that we have the spring balance, and the spring balance is just used to suspend a pulley system. Which is further used to suspend a system of two blocks here. Like this. Let's say M1 and M2. And P is a massless pulley. So we have to find the reading of the spring balance. Now from our earlier knowledge, we'll understand that the reading of the spring balance is in the tension with which the spring is being pulled downwards. It's equal to that tension. So we have to actually find the tension with which the hook of the spring balance is pulling it down. Okay. So if I just magnify this here, see if this tension with which it's being pulled down here, this is suppose T1. So the reading of the spring balance is actually equal to T1, which I have to find out. Now why I have labeled that as T1 is because see, T1 is acting at the center of the pulley in the upward direction. At the center of the pulley, T1 is acting upwards like this, okay, at this center point, and whatever tension this thread has, tension T is acting like this on it, okay. So coming back here, if we make the free body diagram of the pulley, which is massless by the way, so in that free body diagram we can see that there is tension T1 acting upwards, and this T1 only is what we're looking for because it's the reading of the spring balance. But there are two of these sides of the thread pulling it down with T, and because it is a massless object, so that means its mass is equal to 0. So that means net force on it, which is mass into acceleration, should be 0 because mass itself is 0. So what is the net force? T1 minus 2T, that should be 0. So T1 should be equal to 2T. So that's the first equation now. Okay. What I'm trying to do, I'm trying to find the reading of the spring balance. So the reading of the spring balance is T1, and that T1 is equal to 2T. So next, how I'll find 2T? So to find T, we have to solve the equations from the free body diagrams of the two blocks M1 and M2. But those FBDs will make in which frame? In the non-inertial frame of the elevator. Now, of course, M1 and M2's values are given to us. So this is how we'll solve the problem next. So M1 is given to us as 1.5 kgs and M2 is given to us as 3.0 kg, and we have to take G for this particular question as 9.9 meters per second square. So from all this information, we have to ultimately do what? We have to find T, so that we can substitute that here. We'll get T1, and that is nothing but the reading of the spring balance. So just note this up to this point and start working on the next part where you have to do this. You have to make the free body diagrams of the two blocks M1 and M2 in the non-inertial frame and solve for T. So once you get T, you know that reading of the spring balance is nothing but T1, which is 2T. Okay, so Kunj, hope you have understood the question up to this point. Okay, so now do that next thing, make the two free body diagrams. Remember, you're making it in the non-inertial frame, so you have to take their pseudo forces correctly. Okay, so let's understand the two free body diagrams. Kunj, if you've done it, just verify the free body diagrams. Okay. So free body diagrams for the blocks M1 and M2 in the elevator's frame. So our reference frame is the non-inertial frame of the elevator, okay, which we know is going up with a vertical acceleration E naught equal to G by 10. Okay. Now in this frame, suppose we assume that M2 being the heavier block is coming down with some acceleration A, and M1 being the lighter block is going up with acceleration A. So this A is the acceleration with respect to the elevator's frame, okay, or with respect to the pulley, because the pulley is attached in the elevator's frame. So that is why when we make the free body diagrams in this frame, the block M1 and in this frame the block M2 will each of them have an acceleration A upwards and an acceleration A downwards. A is the acceleration of M1 and M2 with respect to the pulley P, which is in the elevator's frame. The pulley is fixed in the elevator's frame, so like that. Okay. Now in this frame, of course, the pseudo force acting on each one will be downwards because the acceleration of the frame is upwards. So there will be two pseudo forces on each of the blocks. M2 A naught, which is the pseudo force of this one, and M1 A naught, which is the pseudo force on this one. Then of course there will be tension, which is acting vertically upwards on each of the blocks. And then of course there is the individual weight of each block. So M2G, M1G. So we have for the equation for the block M1, we have the equation T minus M1 A naught minus M1G is equal to M1A. And for the second one, we have the equation that the sum of pseudo force plus weight, pulling it down, but going against tension, so minus T is equal to M2A. This is our second equation. Now we need to solve these equations to find T. So we need to find the tension in this. Okay. So substitute M1 as 1.5 and M2 as 3 kg. So, and of course A naught as G by 10. So equation 1 will become like this, that T minus 1.5 into G by 10 plus G is equal to 1.5 A. And equation 2 will become like this, T minus, oh sorry, T into A naught, which is G by 10 plus G minus T is equal to 3A. So this equation further we can write as T minus 1.5 into 11G by 10 is equal to 1.5A. And this equation further we can write as 3 into 11g by 10 minus t is equal to 3a. So now see, we want to solve these two equations for t now. T is the unknown. So we want to eliminate a. So to eliminate a, take equation 1 and divide it by 1.5 and equate it with equation 2 divided by 3. So the left hand side for both the equations is equal to a, and that should be equal to the right hand side. Sorry, the right hand side is equal to a, which should be equal to the left hand side. The RHS for each equation, when you divide by 1.5, this one is a. You divide by 3, this one is a. So that should be equal to left hand sides. So a should be t upon 1.5 minus 11g by 10, and on the other side that should be equal to 11g by 10 minus t upon 3. So from this now we can easily solve for t. So t into 1 by 1.5 plus 1 by 3 is equal to 11g by 10 plus 11g by 10. So you can write this as g by 10. So t is working out to 22g by 10. So now going back to that, t1 is 44g by 10. So the spring balance will read a tension T1 of 44g by 10 or 4.4 Gs. Okay. And notice the answer given at the back will be 4.4, okay, instead of 4.4 G. So it is understood. Okay. If the tension is 4.4 G, it is equivalent to a mass. So a tension of 4.4 G is equivalent to mass of 4.4 kg. So if we are giving the answer of the reading in kilograms, we should just write it as 4.4 kg. Okay, so first of all, make sure you understand the free body diagrams properly and come up to this set of equations. Okay, rest of it is substitution of these values. Substitute these values in equation 1 and 2, and then rest of it is solving here. Solving for the tension. However, go through all the steps carefully and let me know if there are any doubts and questions. Okay, so Kunj, hope this is clear to you. Okay, so hope the final answer is clear. Now let's move on to question 17. Okay, so question 17 next is saying that you have a block of given mass is suspended from the ceiling through a massless spring of spring constant K, which is given to you. What is the elongation in the spring? So in the first case, it's very simple. All you have done is you have suspended a given block using an ideal spring. So an ideal spring we had discussed last time is massless, like this, okay, of spring constant K. So because of the weight of the block, this will develop a tension, and that tension will depend on that tension will be equal to Kx, where X is the extension of the spring. So the spring will be in an extended state, elongated state. Okay. So for the block, you can see the tension is equal to mg, or the tension is Kx is equal to mg. So the extension of the spring X is equal to the weight of the block divided by K. So X here is equal to, now mass of the block is given to us in the question as 2 kgs. So 2 into, we will take G as, nothing is given, so we'll have to take G as 9.8 divided by the spring constant, which is given to us as 100 newtons per meter. So this is in newtons divided by Newton per meter. Okay, so this is becoming 19.6 by 100 meters, or you can say X is equal to 19.6 centimeters. So this is the first part. Now in the second part in the question, if another 1 kg block is attached, what will be the further elongation? So now what you're doing is, You already got this block of 2 kg, and to that you are attaching another block of 1 kg. Okay. So as a result of this, now the spring is getting elongated even more. It has become, let's say, x prime, where x prime is the initial extension plus a further extension. Okay. X was this much. Okay. So it's got further extended by delta x. So we need to calculate delta x. So for that, what you can do is you can make a combined free body diagram here of both the weights put together. So the total weight acting, that is being balanced by the new tension in the spring, which is kx prime. So kx prime is equal to the combined weight. This becomes our new equation. Okay. So the new amount of extension here, that is 3 into 9.8 divided by 100 in meters. Okay. So our new extension is this much. So comparing this and this, you can see that it has got further elongated by this much, or 9.8 centimeters. So by attaching the 1 kg block, we have got a further extension, or the extension has increased by how much? 9.8 centimeters. So very easy question, as you can see, nothing difficult in this. Okay. Note this down, and we will also discuss question number 19 next. Okay, 19 is a slightly different problem, so I want to discuss about it. Okay. I've taken G as 9.8, so I'm getting this. If you take G as 10, then you will get X as 20 centimeters or 0.2 meters, and you will get X prime as 30 centimeters or 0.3 meters. Therefore, you will get delta X as 0.1 meters. But that is if you take G as 10 meters per second square. We have taken G as the more accurate value, 9.8. So okay, so this question is clear. Read through question number 19. I'll explain it in detail. Okay, so question 19, it involves a hot air balloon, okay, and some mass suspended to it. So let's say this is the mass suspended to a hot air balloon. Now the question says that the buoyant force or upthrust acting on the balloon remains constant. B is the buoyant force, or you can also think of it like upthrust applied by the atmosphere on the balloon, okay, upwards, and this is a constant force. Okay. So that's one force acting on the balloon, and obviously the weight of this thing is another force. We'll neglect the weight of the balloon itself because it's filled with helium, which is very light. I think in addition to that, there is also a third force, and that is the force of air resistance. Okay, now it says that also air resistance force, let's say R, okay, acts on the balloon such that the magnitude of R is proportional to the velocity or the speed, and direction is opposite. It is opposite to the direction of velocity. So in other words, we can say that R is equal to some minus CV, where C is a constant. So the magnitude of the resistance force is CV, and direction is opposite velocity. Okay. So now it says that in the first case, when we have attached a mass m, the balloon happens to be going up with a constant velocity. So it's going up at this point of time with constant velocity. So that means its acceleration is zero. It is ascending at constant velocity. So when it is ascending, what is the direction of the air resistance force? It will be downwards, because the direction of air resistance force is opposite to V, and its magnitude will be how much? It will be equal to CV. Okay. So since it is ascending at constant velocity, we can say that acceleration is zero. So forces have to balance. So buoyant force has to balance R plus mg, or this buoyant force has to be equal to CV plus mg. This is the equation that we're getting from the first case. And the second case, what we are doing is we are, okay, oh sorry, in the first case actually we were descending with the velocity v, my mistake. So we need to make a correction here. In the first case, when we had suspended the mass m, but then that mass is also given as capital M. So in the first case, when we have suspended the mass capital M over here, the balloon happens to be descending at constant velocity. So it is descending, means coming down at constant v. So it has a downward direction of motion, and the acceleration is zero because the velocity is constant. Okay, so this equation will change, because if the direction of velocity is downwards, what about the direction of air resistance force? That will also be upwards. It has to be opposite velocity. R has to be opposite B. So now my equation is that B plus R are together balancing capital Mg, or B plus CV is equal to mg. This is my first equation. Okay. Now in the second case, what we are doing is we remove some mass. The rest everything is the same. The balloon is the same, but we are decreasing this mass and making it some m prime, let's say, where it is capital M minus delta m. So when we remove this mass, what we observe is that it starts, instead of coming down at constant velocity v, it starts ascending at uniform or constant v when that much mass is removed. So again, its acceleration is 0. So this time, buoyant force will be the same because we have discussed buoyant force is constant. It is independent of everything else. Okay, this is a constant force. Okay, but the other two things are changing. The weight is changing to m prime g. Okay, and the air resistance force, उसका direction अभी क्या हो जाएगा? नीचे की तरफ हो जाएगा. This r will be cv downwards because r is opposite to v. So now v is upwards, so r is downwards. So for the second time, the equation will become what? That this time, buoyant force is balancing this plus r, or b is equal to m prime, which we are writing as m minus delta mg plus cv. Now we have to find out delta m, how much mass we are removing. So for that, we can just do one thing: compare equation 1 and 2, add them. Okay, so to find m, what we do is add equation 1 plus 2, and you will get the value of delta m, how much mass is being removed. So just try this out. So make a note of the diagrams and make sure you understand the equations that we've got from the free body diagrams. Okay. This, of course, is the explanation of the question which is given. So this information is given in the question here. This is where we are applying it. So one time when we have suspended the mass capital M, it is going up with a constant velocity v. Sorry, it is coming down with a constant velocity v in the first case. So the air resistance force is upwards. It's opposite to the downward velocity. The second case, when we have removed some mass from it, it's become lighter. So now it starts going up with a velocity v. Now when it's going up with a velocity v, the air resistance force is downwards. Okay, yeah, Ruksa, that's correct. Okay. So finally, adding the two equations, you will get this result that equation 1 plus 2 here will give you that, okay, 2b on the left hand side will be equal to CV will cancel out on both sides. Okay, so 2m minus delta m g. So delta m will become 2 times b by g minus capital M. This kind of result we'll get. Oh, sorry, the other way around. M minus. Okay, so hope this question is clear to all of you. So we'll conclude today's session here. Now, Itanju, since you asked about the DPT, now at this point of time, I don't have information about what topic is there for the DPT, but I will find it out and get it announced in your WhatsApp group so that you know. It will be some single topic either in maths or physics because you had chemistry in the last week, I think, right? Has it been announced for you or not? It's not been announced, right? Has anybody made an announcement? No, not yet. Okay. So I will ask them to make the announcement. Okay. I don't have the information just now what is the DPT topic, but I will find it out and get it announced in your group. Okay. So that's it for the class today. And now target on finishing the HC Verma exercise of Newton's laws of motion, because next time we will definitely be starting with friction also after discussing few of these questions. Okay. So if you go through the next few questions, you can see, especially from question 23 onwards, 22, 23 onwards, they are all standard pulley mass type of systems. And we've been discussing a lot of those questions in class. So if you just revise the questions done in the last 2 or 3 lectures and then try out these questions, you should not have too much difficulty. So please continue working on them over this week, and we will discuss a few more of them in the next lecture we have. So that's it for today's class, people. Wish you all the best.